problem, using the kinematic equations, the algebra won't be as simple as in other cases. And in particular, with a situation like this, where we have a y displacement, we have an initial velocity, we have the acceleration, and we're trying to find the time, we would have to use the third kinematic equation. And in this case, we can't algebraically solve for time without using the quadratic equation. A couple things to take note of in this particular problem. Since you're starting at a higher point than you're ending, the displacement is going to be negative. And if we use the third kinematic equation, the fact that the ball goes up before it comes down will all be taken into consideration. We use the third kinematic equation, but again, to solve for time, since time appears in multiple places, and it's squared in one place, not in the other, and in the third time there's no delta t at all, we do have to use the quadratic equation to solve this problem. The first thing that we'll do is set this equation equal to 0 and put it in the form of ax squared plus bx plus c equals 0. So I will subtract delta y from both sides. And when I do that, the 1/2 a, the 1/2 the acceleration, becomes my a term, v1 becomes my b, and the negative delta y becomes my c. You should be familiar with the equation to solve for x using the quadratic, negative b plus or minus the square root of b squared minus 4ac all over 2a. If we use that, we're actually solving for delta t in this case, so we'll have negative v1, which is our b term, plus or minus the square root of v1 squared minus 4 times 1/2 the acceleration, which was our a term, times a negative delta y, which was our c term. That goes over 2 times our a term, which was 1/2 the acceleration. Your best bet is to reduce this algebraically before you start substituting numbers in. So when we do that, we'll have v1 squared, negative 4 times 1/2 is negative 2 times a negative is positive 2a delta y. Now that is strictly algebra and mathematical negatives. The 1/2 and the 2 in the denominator cancel, and we're left with acceleration. We haven't yet considered any of our givens and whether or not they are negative, but now that we're ready to substitute, we will consider that. Our initial velocity was 25 meters per second. If this was something that was thrown downward, we'd have a negative 25 meters per second as our given, but then algebraically that would be the second negative. You have to be careful about the signs for the givens. Like we're putting in a negative 9.80 meters per second squared and a negative 95 meters. And then we divide by a negative 9.80 meters per second squared. When you solve this, you notice that you have the plus or minus here with the square root. It's a good idea to do both. One of those two answers will make sense. For example, you can never have a negative time. So when you do substitute this into your calculator, check both answers and see which one is suitable for the particular problem. The correct answer for this is 7.6. I encourage you to type it into your calculator and make sure that you can get it. Watch your negative signs. The negative 9.8 and the negative 95 do cancel. There's also a negative in the denominator here, as well as with the velocity 1 due to the negative in the quadratic equation. For the second part of this problem, we're looking for the maximum height. So you notice you're not going to use the negative 5 as a given because we're looking for delta y. The negative 95 is how high the cliff is, but we're trying to find where this goes at the highest point. So instead of using that as a given, we're going to use the fact that at the maximum height, we have a velocity momentarily of 0, and that would be of v2. In this case, our position 2 is at the highest point. So when we're trying to solve for delta y in this situation, the fourth kinematic equation becomes useful. We'll rearrange that for delta y by subtracting v1 squared and then dividing by 2a. At the highest point, again, the velocity has reduced by 9.80 meters per second every second. So at the highest point, it has reduced all the way to 0 before it turns around. Plug in the rest of our values. Type that into the calculator, and we get 32 meters as our maximum height.